Okay, I heard that chapter 7 wasn't working right, so I'm going to try again. Chapter 7 is all about light. We're not concentrating on sound, and so the only things that I will talk about in chapter 7 are the properties of light, reflection, colors, refraction, and 5 and 6 we will not discuss. So the first thing is that light travels in a straight line. It travels at a speed about 300,000 kilometers per second. It can go around the world 8 times in 1 second, which means it is traveling very fast. It travels much faster than sound. So giving you 2 examples, I always do it with my kids, thunder and lightning. They start at the same time, but you'll always see lightning first. So I always tell them, if you see the lightning, just prepare yourself and know that the thunder is coming. When you see a starting pistol fire, you'll see the smoke first and then hear the bang, as they say. And so this lets us know that light travels much faster than sound. So why do you see things? It's because they reflect into your eyes. You have something called rods and cones. It's called the movie projector. They see things taken color, projected back onto your lenses, and therefore you're able to see. Well, that's how our normal basic concept of how do we see things goes. When you see things, they're either luminous or non-luminous. Luminous means that they produce light, so it's like the light in this room or the light bulbs in your lamps or the headlights on your car, where non-luminous will reflect lights. And 2 examples of that would be like your mirror reflects light, as well as metal. It reflects light. When light is blocked, we see that there are shadows that become in place. So as it shows here, you have a tree, the sun, and this is how we produce the shadow. So in summary, you have several properties of light. It travels in a straight line. It travels much faster than sound. We see things because they reflect light into our eyes, and shadows are formed when light is blocked by an object. So this will tell you exactly how you should look for the question on the test. I usually say all of these are properties of light except, and so that helps you out. Moving on to reflection. Reflection is simple. You always have this normal plane, and then you have light that comes in, known as the incident ray, and then the light that comes in and bounces off the mirror goes out, known as the reflected ray. And between these is angles that are created. In the incident ray, you have the angle of incident, and in the reflection ray, you have the angle of reflection, which makes sense, right? So the law of reflection, states that the angle of incidence is equal to the angle of reflection. In other words, light gets reflected from a surface at the same angle it hits it. So if you had a test question that said, I have an angle of incidence of 20 degrees, what is the angle of reflection? And so this is the time that you do not say, she never taught us that. What you remember is that the angle of incidence is equal to the angle of reflection. So you know if the angle of incidence is 20 degrees, then the angle of reflection must also be 20 degrees. And so this is the simple concept of the law of reflection. When you have angles coming in, you can have a smooth, shiny surface, and this gives a clear reflection because the angles come in and go out at the same angle, or the light comes in and goes out at the same angle. Then you can have a rough or dull surface and get a diffuse reflection. And a diffuse reflection is when the light gets scattered. This is what you see when you go into a haunted house. And then you have, not the haunted house, the house of mirrors, right? And so it'll make you really tall or really thin or really short or really fat. Those are because the mirrors are concave and convex in certain places, causing the light to bounce off in a different direction, creating the image that you see. So when we talk about light and we talk about it bouncing off a surface, there are 2 surfaces that you can have. You can have a clear reflection or a diffuse reflection. All right. So we will